of the dimensional analysis, the data analysis PowerPoint. We really only have one more slide to look at, and then we'll do some sample problems. And that's dimensional analysis. Now that's just a fancy name for converting. And when you do a dimensional analysis, you use what we call conversion factors. And all a conversion factor is a relationship between two measurements. Sometimes the measurements can be the same system, like both of these are metric system. 1 meter is equal to 100 centimeters. But sometimes they can be connections or bridges, if you want to call it that, between the metric and the English system. So this one right here, 1 inch equals 2.54 centimeters. Well, that's a connection between inches, an English unit, and centimeters, a metric unit. Then, of course, you can have conversion factors for English only. For example, 1 mile equals 5,280 feet. That is a conversion factor between two distances in the English system. 3 teaspoons to 1 tablespoon. So you can call it, so this is a cooking conversion factor. For every 3 teaspoons you have, that's 1 tablespoon. And then another connection between mass and weight for metric versus inches. 1 kilogram of mass is equal to 2.205 pounds. And one of the things we haven't discussed is how this relates to significant figures. Earlier, we talked about exact numbers. And we said that exact numbers had infinite significant figures. So when you're dealing with certain conversion factors, sometimes you're dealing with exact numbers. For example, there is exactly 1 meter in 100 centimeters. So I could put 1.0 or 1.0 infinitely and still mean 1. And I could put 100.0, 100.00. I could put infinite number of zeros on this. It wouldn't matter. So when we're multiplying and dividing, and we use a conversion factor like this, we have to remember this is exact. So if I'm looking for the least number of sig figs, I'm not going to count these because they have infinite sig figs. Same thing down here, 1 mile equals 5,280 feet. There is exactly 5,280 feet in 1 mile. There's exactly 3 teaspoons in 1 tablespoon. It's when you get to the metric English conversion factors, like this one here and this one here, that we start to have to deal with measured values because these are approximate. The ones will always be exact. So the ones will always be infinite. Exactly 1 inch equals approximately 2.54 centimeters. So if you see a decimal number like 2.54, or down here 2.205, those are numbers that you cannot count as infinitely significant. 1 kilogram, exactly 1 kilogram, is equal to approximately 2.205 pounds. Exactly 1 inch is equal to 2.54 centimeters. So be careful when you're rounding using your dimensional analysis. All right, let's do our first example. All right, the question says, how many centimeters are in 45.2 inches? The first thing that I want to do is I want to figure out where I am going. Where am I going? I'm going to centimeters. So I'm going to write a question mark. I'm going to write centimeters. And I'm going to set that equal to whatever the given value is. In this case, 45.2 inches. Now I'm not setting up a proportion here. So this part of the dimensional analysis is really just to tell me when to stop. The math doesn't start until the right side of the equal sign. All right? So don't worry about the left side. That's just going to help you figure out when to stop doing the problem. All right? All right, now we're going to make something very similar to what we did earlier with our metric conversions. We're going to put a bracket. And sometimes this system, dimensional analysis, is called fraction labeling. And that's what these are. This is a fraction. In fact, I could put a 1 here, and it'd be 45.2 inches over 1. I could leave it there, or I could take it out. It really doesn't matter, because a 1 in the denominator position doesn't affect the outcome anyway. All right, now I need to think of, okay, I'm trying to get inches to centimeters. Is there a conversion factor that I can look up on the handout that gives me a connection between inches and centimeters? And you start looking, and around the area that says metric to English conversions, you see that 2.54 centimeters equals 1 inch. So there's our connection between the two. I can go directly from inches to centimeters without having to use what we call a bridging unit. In other words, go to here, and then go to here, and then go to here, and then finally get to centimeters. I don't have to do that. I can go directly from inches to centimeters with just one step. So I'm going to do that, but I'm not going to put any numbers. I'm going to put units first. So we go up to our bracket, and I'm going to put whatever unit I'm trying to cancel. I'm trying to cancel inches. I'm going to put inches on the bottom. And what am I trying to get to? I'm trying to get to centimeters. Now earlier when we did our example over metrics, we said at this point, ask yourself which one is bigger. You can still do that, but it's easier just to go down here and look at your two numbers. What number do you see next to inch? I see a 1. Okay, well, we're going to put a 1 there. What number do you see next to centimeters? I see a 2.54, so we're going to put a 2.54 right here. Or I could have said inches are bigger, so I put a 1 there, and there's 2.54 centimeters in 1 inch. Either way would have worked. I'm going to cancel out my inches, and then I look and I see where I am. Centimeters is where I've converted to, and what do I see next to the question mark? I see centimeters. That means I'm done converting, I'm ready to multiply or divide. Okay. So, am I ready? I am. Am I multiplying or dividing? Well, you could say you're doing both. You're going to multiply by 45.2, and think of it, it's really, all you have here is 45.2 over 1 times 2.54 over 1. You're just multiplying the numerators. The ones don't really count. So I get my calculator, and I say 45.2 times 2.54 equals, and I get 114 point, what was that number? 114.808. All right, now we have to round. I tell you earlier about rounding. Well, we're multiplying and dividing here. So the rule was what? Look for the least number of significant figures. What about the ones? What did I teach you about ones? Ones have infinite significance. So is the 1 the least number of sig figs? No, it has infinite sig figs. Is the 2.54 an exact number? Now it's a decimal number. Remember, you treat decimal numbers as measured values. 45.2, a good rule of thumb, anything that goes here, which I call the given value, always treat that as measured. In other words, always treat it as a certain specific number of sig figs. So how many sig figs do you see here? 3. How many sig figs here? 3. What's the least number of sig figs? 3. So, what is the third sig fig in 114.808? Well, this is the first one. This is the second one. That's the third one. What do you see next to the 4? I see an 8. What does that cause the 4 to do? Causes it to go up to 5. So this rounds to 115. Don't forget your unit, centimeters. And there is your answer for the first dimensional analysis problem. They do get a little more complicated than this. They get a lot longer. Sometimes you have to deal with exponents, scientific notation, and also derived units. In other words, converting 2 units at the same time. So this is the end of the data analysis PowerPoint. I'll come back with some more dimensional analysis practice problems in the future.